All right, we're working on sums and differences of rational expressions. And Algebra 2, I'm so proud of you guys. You guys are doing awesome with factoring. So now we're going to learn how to put it all together with these rational expressions. A sum is something that is being added. You guys probably know that. A difference is something that's being subtracted. So as you can see, we're adding on number 1 and subtracting. Rational expressions are these rational expressions that have factoring in them, A's and B's. They're not just fractions, but since they are fractions, we do need to have a common denominator. So if I have 6a squared, 3b squared, and ab, between the numbers 6 and 3, my common denominator would be 6. And then I would have a squared and b squared, because remember, we need the least common denominator, which is the greatest amount of variables. So, to get from 6a squared to 6a squared b squared, I need to multiply by b squared over b squared. I can multiply anything through by 1 and not change the value. To get from 3b squared to 6a squared b squared, I need to multiply by 2a squared. To get from ab to 6a squared b squared, I need to multiply by 6ab over 6ab. Again, I can multiply anything through by 1 and not change its value. So on the top, 1 times b squared is b squared. Plus 1 times 2a squared is 2a squared. And a negative 2 times 6 is negative 12ab. And that is our answer. So I'm going to go ahead and circle that, and we'll move on to the next question. All right, what if I have the denominators y squared plus 1 and y? The common denominator is actually going to be y times y squared plus 1. Because of this addition right here, this y can't go into y squared. It would have to be able to go into both. So mathematically, we can't do that. So I have to take everything and make it y times y squared plus 1. So to get from here to y squared plus 1, I need to multiply each by y over y. To get from y, I'm going to multiply by y squared plus 1 over y squared plus 1. And it looks like I get 2y plus 5y squared plus 5. Now, a lot of you are probably thinking, well, what if this can reduce and factor? So let's put this into our regular form of 5y squared plus 2y plus 5. And you can just leave this as y times y squared plus 1, because sometimes these would FOIL through, factor through and be able to reduce. But let's go ahead and check this. If I take first times last, I get 25. Are there any factors of 25 that add up to be 2? No. So I know that this is just my answer. If you showed it like this, that would be fine as well. All right, moving on to example 3. Sometimes we do have to factor. So the factors of negative 6 that add up to be 1 are x plus 3 and x minus 2. The factors of 2 that add up to be negative 3 are x minus 2 and x minus 1. So because we need a common denominator, there are some things in common. This x minus 2 is in common. So I know we're going to need 1 x minus 2. X plus 3 and x minus 1 are not the same, so we're going to need an x plus 3 and an x minus 1. So our common denominator is x minus 2, x plus 3, x minus 1. Now, to get from this x plus 3, x minus 2 to here, I need to multiply through by x minus 1 over x minus 1. Again, I can multiply anything through by 1, and it doesn't change the value. To get from this x minus 2, x minus 1 to here, I need to multiply by x plus 3 over x plus 3. So let's go ahead and distribute. Ooh, this is another negative 2. I feel like we just had one of those. 3x minus 3 minus 2x minus 6. And yes, we do have to add like terms. 3x minus 2x is x. Negative 3 minus 6 is 9. All over x minus 2, x plus 3, x minus 1. All right, there's one more that I really need to go over. Star circle highlight this because I see these all of the time. So I'm going to put a big yellow star. These are all over. This is a great ACT, SAT question. All right, so this looks really familiar. B minus A looks so similar to A minus B, but we have learned in Algebra 1 and in Algebra 2 that subtraction is not commutative. So what we always do, and for some reason we always do it to the second part, is we are going to factor out what we call a negative 1. So I'm changing this plus sign, I'm changing it to a negative sign, and it's like factoring it out. You know, if I was to distribute this back through, negative times negative A would be positive A, which is where we were, and negative times positive B would be negative B. But I'm doing the opposite of the distributive property to get to this. So now B minus A is the same as B minus A. So now I have a common denominator of B minus A. Well, on the top, it looks like I have A minus B. Don't these look awfully familiar? Yeah, I think they look so alike. So let's try that again. Let's factor out a negative 1 again. When I do that, I now have A minus B and A minus B. So those can cancel. And I have 1 over negative 1, which is just negative 1. These questions I see all the time. They don't always cancel out to be a negative 1, but sometimes you just have numbers on top. So please be aware that anytime you see like a B minus A and an A minus B or an X minus Y and a Y minus X, it is going to have to be that factoring out of that negative 1.